Good morning, everybody. So, in the last class, we were discussing about the various problems related with machines and various question papers we have discussed. Today also we'll be having a discussion with the various GET question papers. So, you have to be having a familiarity of what type of questions will be asked. Okay, that is very, very important. What type of questions will be asked and how the questions we have to solve, because all these problems we'll be learning as 13 mark, 16 mark questions we'll be solving. We'll be solving about 2 or 3 pages like that. But here, what is the thing here is the given data, everything is given, and they have just given 4 options. So it is important for us to find out the data and find out the answers within proper way. Okay, that is very, very important. So I think we have completed the. We are going to start with the eighth one. I think we are discussing. So here, what is the question given? We have to see it out. Okay. So here, the locked rotor current in a 3-phase star connected 15 kilowatt 4-pole 230 volt 50 hertz induction motor at rated conditions is 50 ampere. So regulating losses and magnetizing current, the approximate locked rotor in a line current drawn when the motor is connected to 236 volt 57 hertz supply is. So they are asking to what is the current approximate locked rotor line current they are asking. So they have given some data here. Okay, so firstly, what is the first step is every time when you before solving a problem, you need to write the given data. That is very important. Okay, so without the given data, it will not be a problem. So I'll share that. I'll just copy this question. Okay. So the question, I'm just pasting it. This is the question given. Okay, so this is the question given. So first we have to write the given data. What are all the informations we can get from here? So we have 2 voltages. Okay, we have 2 voltages and we have 2 sets of frequency. If you see 50 hertz is 7 frequency. So we have 2 voltages, 230 volt you have and 236 voltage. We have 2 voltages. So we are going to write it as given data. What are all the given data? So, but all these process should be very fast. Okay, you should not be very slow in writing all this process because it takes a lot of time. So you have to be very careful in solving all these problems. One minute. So here, what is the value given? You have to see it out. So E1 is the voltage. E1 itself. Make it as someone. Okay. So E1 voltage. So E1 voltage or V1, whatever you want, you can take. Just 230 voltage. Then what is that E2 voltage? E2 voltage will be equal to 236 volt. So 2 voltages are given. Then we have frequency. We have 2 frequencies. Okay, so everything you have to understand. And we have the 2 resistance values. Now we should know the formula. We need neglecting losses, transmitting current. What is the line current drawn from the motor? Okay, drawn when the motor is connected to the line. Okay, so here you should know that formula I2. So generally I is equal to V by R. So here it is E2 by Z2. Okay, so since it is an impedance we are taking it as E2 by Z2. So what will be E2? We just write it as it is. So impedance, what is impedance? Z is root of squared plus x squared. Okay, so if it is Z1, R2 squared, X2 squared will be getting. If it is Z1, R1 squared plus X1 squared will be getting. So here it is square root of you will be having R2 squared. Okay, so it is R2 squared. I'll write in capital R2 squared plus X2 squared. Okay, so R2 squared plus X2 squared is value you're going to substitute it here. So this is the value. Okay, so R2 square plus X2 square is the value. So here we are having neglecting the losses and magnetizing current. So here what is the case here is here R2 will be equal to 0. So R2 is equal to 0. So R2 is equal to 0. So you're going to substitute in this expression and find out. Okay. So here what you will get now? You will be having I2 will be equal to E2 by Z2. Z2 I have written it as square root of R2 squared plus X2 squared plus R2 squared is 0 here. So automatically your formula will finally it will become as E2 by E2 divided by so R2 is 0 means X2 squared square root of X2 squared. So automatically square will get cancelled and you'll be getting the value as X2. We'll be getting it as X2. So now tell me what is X2? X is equal to is the reactance. So we can write it as omega into L2. So that value you can write it as E2. So all these formula you should be knowing. Okay, without that it will be difficult for you to understand. Always please know in writing all the formula. That is very, very important. So we are giving the term as omega. Try to see whether we have. So you will be getting the value omega into and L2. Okay, L is the inductance value you will be having. So you will be substituting the value of omega L2. So what is actually omega value into you will be writing it as L2. So that is up by so this formula when you see it is directly proportional to E2 by F omega into L. Yeah, so that what we have to do is it is directly proportional. So directly proportional to and we're putting this alpha value. I'm going here. Sorry, no need of equations. This is directly proportional to E2 divided by F small f. Okay, so we have found out. Now we know the values. So all these, this is the general expression. Now using the ratio, we are going to find out I2 dash. Here, what is that? One current is given as 50 ampere. Yes, I1 current is given as 50 ampere. So we are two voltages are given. So when you substitute this in this ratio, you'll be having 50 divided by I2 dash. So I2 we have solved using this formula. So 50 divided by I2 dash. 50 divided by I2 dash will be equal to, you have two voltages. What are the two voltages? 230. The one voltage is 230 and another one is 236. No? So 230 divided by 236 into what are the two frequencies you have? 50 and 57. Okay. So these are the two frequencies you have. So frequency is 1 by f. So you have to write in the opposite order. See, actually for 230 volt, your frequency is 50 hertz. For 236, it is 57. Since it is 1 by f, what will happen is it will get inverted. So it will be having 57 divided by 50. 57 divided by 50. Now when you solve this, you'll be getting the value of I2 dash. So that is the, this, anybody want to solve me and say this answer. So 50 divided by I2 dash will be equal to this value. So from that, when you calculate it, you will be getting the answer. So what is the answer is 45.0 ampere. So 45.0 ampere. So this is the answer. Okay, so here this is the expression. So for given data, what is the given data you have to write? Given data and formula is very important. Okay, so they are asking to find out the what they are magnetizing current. They neglecting these losses. They are asking to find out the rotor line current that is drawn from the motor. So that this is the expression. So these are the basic equations only. But at the time of examination, you should be able to recall all these formulae. That is very important. Okay. So without the recall, you should know all the formulae thoroughly. That only it will be easy for you to solve any of the problems. So all the formulae, please, what is my opinion is, you just take one sheet and you write all the formulae. What are all the possible formulae you have? So please write it separately. Okay, separately, and you keep it with you, so it will be easy, and you can go through the formulae a number of times. So the denotions may vary. Denotions may vary for each and every type, but the informations or the data is same. So it will be easy. Okay, all of you please follow this properly. So now we'll go to this. So the locked rotor, current rotor, when you see that the answer is 45.0 is the answer. See, whenever you see the two options, we have already told you many times, two options in the gate will not be reliable with each other, will not be related with each other. Definitely you can odd man it out and take it out, but other two options will be closely related with each other. So you have to be very careful when you write the answer, especially for theory also. For four options, two options will be more or less similar to each other. So you have to be very careful identifying it. Okay. Okay. So we'll go to the next problem. So we have one theory, we'll see it out, then we'll go for this. So here we have a problem. Sorry, theory part. A 4-point starter is used to start and control the speed of. So it is a 4-point starter is used to start and control the speed of a dash. So what is the purpose of the 4-point starter? Okay, that is the thing here. So here we have four options: DC shunt motor with armature resistance control, then DC shunt motor with field weakening control, then DC series motor and DC compound motor. So what is that answer? Anybody has an idea of it? Yes. So what is that purpose of the 4-point starter? So 4-point starter, what we are going to do, what we'll be doing in 4-point starter, when you see the construction wise of the 4-point starter, we'll be using a variable resistor which is connected in series with the armature resistance. Okay, we are going to connect a variable resistor which is in series with the armature resistance. Why? Because we are going to limit the starting current. Okay, so if you see these four options, which will be more reliable? If you check it out, the first one is DC shunt motor with armature resistance control. So here, when you connect a resistor, when you connect a resistor in series with the armature resistance for controlling the starting current, so automatically it will control the armature resistance. So option A will be your correct answer. Okay, so DC shunt motor with armature resistance control, that will be your correct answer. Okay, so you should be knowing not only 4-point starter. Again, you have to go for 3-point starter. Okay, all the 2-point starters everywhere you should be knowing where it is applicable, where it is applying. Okay, everything you should understand. Okay. Next question. A three-phase salient pole synchronous motor. Three-phase questions will be in a mixed form. They will not ask only the same questions. Okay, the question will be in the mixed form. It will have series motor, shunt motor, synchronous motors. Everything will be related. So you have to be careful and you have to identify which type of question is asked and what is the formula used. Everything you should be knowing. Okay. So a three-phase salient pole synchronous motor is connected to an infinite bus. It is operated at a no load under normal excitation. Next, the field excitation of the motor is first reduced to zero and then it is increased in reverse direction. So what will be the armature current they are asking? Okay. So three-phase salient pole synchronous. What is the synchronous? Means it's constant speed motor. Okay. It is connected to an infinite bus we are connecting. It is operated at no load under normal conditions. So initially there is no load. The field excitation of the motor is first reduced to zero and then it is increased in the reverse direction. So what will happen to the armature current is the question. So armature current, how it will be there? Okay. So what will be the answer? So first they are given that the armature current will be increasing continuously. Next one first increases and then decreases. Third one first decreases and then increases, and fourth one remains constant. So what we are doing is first we are reducing the field excitation to zero and then we are increasing in the reverse direction. So what will happen here is first what will happen? It will increase, then automatically it will decrease. So this is the correct answer. So armature current will be going on increasing, and then since it is we are reversing the direction, what will happen? It starts decreasing steeply. So first increases and then decreases steeply is the right answer. Okay. So all please understand it properly. So all this logically they will ask. So each and everything you have to just understand. Don't by heart any of the answers. You can't by heart also because same type of question will not be asked, but related to this, many questions may be asked. So when you see a lot of gate questions and you practice a lot of questions from the gate question papers, no previous question papers, definitely you'll get an idea of how what is will be the type of the question given and how the question format will be. Everything you can understand. Okay. Next question, if you say a single phase air core transformer fed from a rated sinusoidal supply is operating at no load. The steady state magnetizing current drawn by the transformer from the supply will have a waveform. So they have given a single phase air core transformer. They are using an air core transformer and it is fed from the rated sinusoidal supply. So we are giving supply, sinusoidal supply we are giving. It is operated at no load. So under no load condition, it is operated. The steady state magnetizing current on by the transformer from the supply. So what will be the waveform? How the waveform will be for that magnetizing current they are asking. Okay. So any idea in the for this? So what will happen is since it is air core transformer, what is the logic? How the output will be? You have four options A, B, C, D. The sinusoidal wave is being disturbed in various ways. Okay, so in first wave it is one type, and second wave C that is of another type. Third one is a normal sinusoidal wave, and fourth one is distorted, both at the upper and lower end. Okay, so all these things are there. So here, which type of sinusoidal wave will be better? Which will be getting us an output? So what is the logic you have to know here is in an air core transformer, how the BH curve will be. What is BH? B stands for flux density and H stands for flux intensity, correct? So here flux density and flux intensity. So BH curve, when you see for the air core transformer, it is linear. Okay, it is linear. BH curve, when you see for the air core transformer, it is so this point is very important. Single phase air core transformer they have given, no? So here, so the BH curve for this air core transformer, it is linear. So since it is linear, what will happen? The magnetizing current will be perfectly, it is a sinusoidal wave. It is a sine wave, okay, a proper sine wave. So since it is a single phase air core transformer, it's just sinusoidal wave. So your option C is correct. Okay. So all the other options are not. So in this way, they may ask any type of transformer here. They may ask what type of transformer or whatever it is given. You should know the features. You should know the basic features of all these types of the equipments. Okay, whether it is a transformer or machine, whatever it is, you should be knowing its silent features. So when you know its silent features, automatically from that you have to infer the result. Next problem we have a 220-volt DC shunt motor is operating at a speed of 1440 rpm. The armature resistance is 1.0 ohm and armature current is 10 ampere. 10 ampere of the excitation of the machine is reduced by 10 percentage. The extra resistance to be put in the armature circuit to maintain the same speed and the torque. So they are asking. Okay. So what I told you, whenever you have a problem, you first take the problem, write the given data. Okay. First I'll share once again. Stop sharing and then share. Okay. So I'm writing the problem. So this is the problem given. So as I told you before, first write the given data. Okay. So what will be the given data? So here you have a 220 voltage. 220 volt DC shunt motor has a speed of 1440 ampere, 40 rpm speed, and it is having an armature resistance of 1 watt and armature current is 10 ampere. Armature current is 10 ampere. Next, you have read the values. Okay, so here the voltage is given as voltage V is given as 220 volt or E1 is given as, we are taking it as voltage V is equal to 20 volts. 220 volt is given, and your armature current I am denoting it as IA, right? IA will be equal to, armature current is equal to 10 ampere. Armature current is equal to 10 ampere. Then armature resistance is given. The armature resistance is actually, the question is 1 ohm. It should be 1 ohm, not 1 watt here. Okay, so armature resistance is 1 ohm. Armature resistance. So RA is the armature resistance. So it is 1 ohm. So they given this values. Okay, next speed is given. So speed is given, two speeds are given. Then we are taking it as speed n. Take it as speed n is equal to 1440 rpm. 1440 rpm. Okay. Okay. Now, initially, what are all the logics we have to understand? So they are asking, what they are asking is armature current 10 ampere of excitation of the machine is reduced by 10%. The extra resistance to be put in the armature circuit to maintain the same speed. So they are asking the extra resistance. What is the additional resistance you are going to include in the armature circuit to maintain the same speed? And the speed is 1440 rpm, right? So for maintaining the same speed, what is the extra resistance I have to include? That is the question given. Okay. So first we'll find out the back EMF. So we should know, before going there, we should know the formula of vacuum EMF, that is EV2 by, right? Please see it out whether you can understand this ratio. So N by N2 into phi2. phi is equal to this relationship between that back EMF and the speed and flux, everything is related with each other, right? So N2 phi2 divided by, I'll put it in the bracket, N1 phi 1. Okay, so you should be thorough. So whenever necessary, you have to just substitute that equations here. So EB to EB1 ratio, and it is given as and it will just know this. Okay, now find out the back EMF. So EB, just to find out back EMF EB, 1. So back EMF EB1. So what is the formula? E is the formula is equal to V minus I, general formula we know. So substitute same thing here also. So it is equal to V minus V minus yes, V minus IR, right? So V minus IR general electron is this way. So the formula is into V minus IR RV, right? Okay. So this is the 220 minus 6, it is 210 volt. 210 volt, okay. Used by 10 percentage. So then we have to find the additional resistance, what we are going to include to maintain the same speed. Okay. Now here we have to go for another relation. IA1 phi 1. 1 minute. So all the formula, you should be very careful in recalling all the formula. That is very important. Okay. While taking the class, it will be easy. So just while listening also be easy for to understand. But anyway, you have to put a good. You will get the plan. You will be able to recall the formula for all the problems. Okay. So when you know the formula thoroughly, it will be easy for you. IA to right. Okay. This is one relation. You have a relation. From that you find out IA. So here phi 1 by phi 2. IA2 is equal to, from that I'm finding it out. IA1 into phi 1 divided by IA1 into phi 1 divided by phi 2. Phi 1 by phi 2. So from that, we just substitute the values. So what is the relation here is they have given us a 10% extra. So here, when you find it out now, phi 2 will be equal to, keep it separately. I should know the relationship between phi 1 and phi 2. Phi 2 is equal to 0.9 into phi 1. So I have these values, you have to substitute. Okay, so here 10 by 100, 0.01. So you are just taking the value of relationship between phi 1 and phi 2. So phi 2 will be equal to 0.99 into phi 1. Okay. So 10 means 10% is 10 by 100. So what you will get for 10 by 100? 0.1, 0.01. Okay, so 1 minute. I'm sorry. That it here. Okay. So here IA2 is equal to IA1 into phi 1 by phi 2. So IA2 is equal to, what is IA1? IA1 we know. IA1 is actually IDA. Okay, that value is just going to write IA I written now, that is equal to 10 ampere. So this is 10 ampere, 10 ampere into phi 1 by phi 2. So phi 1 is phi 1, or instead of phi 2, what we are going to do? We're going to write phi 2 in terms of phi 1. So phi 2 in terms of phi 1 is 0.951. So phi 2 in terms of phi 1, you're writing 0.9 to phi 1. So this phi 1 gets cancelled. Okay, so IA2 will be equal to 10 into 1 divided by 0. So you will be getting the answer. What is that answer you're getting? It is 11.11. So it is current, no, it is ampere. 11.11. So this is one answer you're having. You keep it here. Okay. So now I'm going to take out the relationship. So in that relationship, I'm just finding it out. EB1, EB2 I have written out. So here, this one. Again, I'm using this relation. So EB2 by EB1 is equal to, so N2, N1, we are not going to consider because you are going to maintain the speed as constant. Since the speed is maintained as constant, it will get cancelled. So now I am going to write phi 2, phi 1. So phi 2 in terms of phi 1, I'm going to write, and I'm going to find out the value of EB2. So here EB2 by EB1 is equal to phi 2 by phi 1. Phi 2 divided by phi 1. Right? Now substitute the value of phi 2 in terms of phi 1. So what is phi 2? 0.9 phi 1 divided by phi 1. Right? So we know the value of back EMF. So back EMF is that values. It is how we have found out one value, no, EB. So this one, EB1. So this is the EB1 value. So EB1 value is 210 voltage. We got the value as 210. So from that we can calculate EB2. So EB2 will be equal to 0.9 into, sorry, EB2 is equal to 0.9 This 5 1 gets cancelled. So 0.9 into 210. So 210 voltage we have found out now. So just to substitute this 210 voltage. So when you substitute this value, you'll be getting answer as 189 volts. So 189 voltage are getting for EB2. Now, what is the question actually? Question is not EB2. Okay, your question is what is your question is what is the extra resistance we have to improve the armature circuit to the resistor? What is the formula you're going to write is? So adding, so EB value is EB2 will be write this stitch. Now adding a series, so we are going to add a series resistor. Adding a series resistor, any any name, no problem. In the armature resistor. So we are going to add a series resistor R in the armature. So the question is given like this. See, extra resistor to be put in the RC. So what will do? So again we told V minus. So V minus IA, same type of formula. So minus A into. So instead of armature resistance RA, you are going to include additional resistance, right? So V minus IA2. So IA2, you are going to substitute all the value 2 V minus IA2 into RA plus R. RA plus. So what is that resistance you are going to find? Extra resistance. Resistance you have no? So it is capital R. That's all. So we know all the values. EB2 we know, EB2 we know, V we know, then IA2 R, everything we know. So we can easily substitute and find the value of the extra resistance R. Yes. Everybody write out. Just to substitute this. So what we do is 189. So 189 is the initial voltage. 220 minus what is IA2? IA2 we found it out as 0.11, right? So 11.11 into armature resistance 1 ohm. Armature resistance is 1 ohm. So 1 plus capital R. So this is the value we are going to find it out. So from that calculate the value of R. Yes, anybody can answer me. So substitute this value. Okay, here what will get here? 189 is equal to 220 minus 11.11 minus 11.11 into R. That's all. So from that, when you calculate, you are getting the answer as S 1. 790. So 1.5 include the armature circuit. Why we are including this? To maintain the same speed and torque. So here if you see the speed, both the speed are same. For that only we are canceling. We are any doubts? Any doubt in this? Okay. Again I will stop and start. So 1.79. 1.79. So option A is the right answer. If you have any doubts, you can ask me, or I'll go to the next problem. Okay. Next problem. A three-phase 440 volt 66 pole 50 hertz 40 cage induction motor is whatever is motor, speed motor is run the slip of 5%, and the speed the stator magnetic field without the zero magnetic field. Okay, so Still, so you are having 120, sorry, 440 volt, then 6 volt induction motor having, right? Okay, the three phase 440 volt motor is given. Motor is given, and you are having process of network details. Okay. So, volt 6 could give the 5%. The speed of this the will stay and the the 5% is 0.5% is or first post check 120 and 20 that the 20 please try the right things. Try to find those, right? The one to the yes, it is yes, very very simple one part of the one minus in theta with the value of that is equal to n r is So what is the and so one is one partial by so that's the question so and we can no it's so so what is key is uh, state the state synchronism. So steady state conditions. Okay, so they are given on okay. Field with respect to the static field will be zero. Always with respect to the data. It is a rotating state. Always the speed of the rotor will be zero. So speed of the rotor with respect to the stator field. So always we are going to have this expression. Okay. So it is 0 5 RPM 0955. You have will be the answer. With the fast not all this for this uh, to get we can from you know uh, um, is equal to 90 that's minus 3. So this is the activity for STI. The options are 0 minus 5, 0 thousand plus so the four options are not exact. That's 0 and minus 3 get the answer. So have to be very careful not be missing. Mostly this time question that in the fourth option none of the above in should be that. Okay. Okay. This is yeah, the questions that there are Okay, Nancy. So if there are changes, you have to first don't make formula. Formula only for the things what so you have to be very careful and right. Like one formula and the something to input can be the machine it's an every machine have different formula. But it is there are standard formula only. We learn it but so standard formula only is properly and learn properly is very important. Uh, the performance is just very the whether it is after so for people or yeah, zero voltage people are leading after the next part. So it's which provides zero solution and full provide without the controller. So what is that? What are they asking? Yes, which provides zero speed regulation is a shunt motor. Okay, so shunt motor it will provide zero speed regulation without any control is provided. So that is the option. Okay, next theory question. This one providing at full load and unity per factor. The shaft load is reduced half with the current L points. For the in the super factor, they check the half in what you in India. You should just have those it is not your possibility. So just adding or reading the main character. For controlling that. Okay. Anything to hear other thoughts be okay. So you can ask yeah, okay.